we have another example where we need to evaluate this limit. We'll need to pay attention to any indeterminate answers we get if we do direct substitution. So we'll start with direct substitution. We'll plug 2 in for x everywhere we see it, and we'll figure out what we get. So 2 squared is 4, plus 3 times 2 is 6, minus 10, all over 2 squared is 4, minus 4. So that is 0 over 0, and this again is indeterminate. So that indicates to us that we can solve this, but in order to solve it, we're going to start with some algebra techniques. So we'll go ahead and rewrite the limit. In my denominator, I see this is a difference of squares, so I'm going to go ahead and factor that. X minus 2, x plus 2. My numerator, well, this is a trinomial. It does factor. I'm looking for numbers that will multiply together to give me negative 10, but will add together to give me positive 3. So hopefully you agree with 5 and negative 2. Notice that x minus 2 is in the numerator and the denominator, so we can cancel those. And then we can rewrite this as the limit as x approaches 2 of x plus 5 all over x plus 2. Now, what's the next thing we should do? If you said direct substitution, you were right on it, so we'll go ahead and direct substitute 2 for x everywhere we see an x, and we end up with 7 over 4, which is our correct answer. So remember, if you start with direct substitution and you end up with something that's indeterminate, before you freak out and be like, oh my gosh, the answer is D and E or something crazy, consider some algebra techniques. The technique we used here was we factored the numerator and we factored the denominator, and then we canceled any common factors, and then from there we finished it off by doing direct substitution. Hopefully this was a nice quick example just to get you in the groove of using algebra inside your calculus techniques. All right, have a good day.